Hey Ashley, let's check this one out. I'm not really sure we need like a binomial equation per se, but I'll show you kind of the steps here. You could use the quadratic equation to solve this, but that always works, and we're not really asked to do that here. We're asked to complete the square. So let me walk you through what you can do here. I personally don't like the quadratic equation. Some people just use it all the time. It always works. I'm more of a factoring type person myself. So let's take a look at this. Right off the bat, we have a GCF of 2, right? 2 would divide in evenly to each of these terms. So let's go ahead and just factor that out. So when I do that, I'm going to get x squared minus 11x minus 4 equal to 0. Now 2 does not really equal 0, so we can basically just forget about that and just work with the trinomial that we have here. Now this trinomial itself is not factorable. There's nothing that's going to multiply to 4 but add to 11. So let's complete the square. What I'm going to do is I'm going to get this 4 over. So I'm left with x squared minus 11x equal to 4. That's going to be my first step. And now I'm just going to focus in right here. So right now I have a binomial on the left, and I want to add half of the b term, which is this term right here in front of the x. So I'm going to take, let me get a different color here. I have negative 11, half of that, and then we square it. Okay? Now, that's not really going to give, that would give us a decimal, so I'll just leave it. Negative 11 squared is 121, so I'll add, my pen would work. So I'm going to add 121 over 4. Because again, when we square a fraction, we square the numerator, we square the denominator, right? So 2 squared is 4, and I have to add that over here as well, plus 121 over 4, and I'll clean up my little scratches over here. Okay, so we're just going to add that to both sides. What that gives me over on the left, that's going to factor out to be x minus 11 over 2 quantity squared. All right, now that probably seems really weird, but because I added half of the middle term squared, I just made a perfect square trinomial. That's where the first term and the last term are perfect square roots. How we can take that down is I make one set of brackets, and I imagine what the square root of the first term is. So the square root of x squared is x, and the square root of this term is 11 over 2. When we take the square root of a fraction, and the fraction itself is a perfect square, we take the square root of the top number, so the square root of 121 is 11, and the square root of the bottom number, square root of 4, gives us 2. And then I just square that whole quantity. You could factor this out old school way. You'd just get x minus 11 over 2 in one bracket, and then x minus 11 over 2 in the other bracket. Over on the right-hand side, 4 over 1, we need to have an equivalent fraction here. So I'm going to make this 16 over 4, and then we can add those together to get 137 over 4. All right, so that's going to be our answer over here on the right, 137 over 4. Almost there. Let me make some more room. See, we don't need equations yet, Ash, right? We're not there yet. So now, let's get x by itself. Obviously, we're going to take the square root of both sides. So over on the left side here, I'm canceling, so there's not going to be any plus or minus or anything like that. I'm just going to have x minus 11 halves, 11 over 2. And over here on the right, we're going to have plus or minus. Now, because I'm square rooting a fraction, I can think of this as the square root of the top number, 137, over the square root of the bottom number, 4. 4 is a perfect square, so I can do that. But there's nothing I can really do with this 137. That's a prime number, so I'm just going to write it as root 137, because I didn't do anything up top, over the square root of 4, which is 2, so I'll leave it like that. Lastly, we'll do a little one-step algebra. Let's add 11 halves to both sides, and we'll express our answer. So, let me get some blue going here. X is going to equal, so we're going to, I always like to put the 11 halves first, so 11 over 2, minus the square root of 137 over 2, comma, and then 11 halves plus the square root of 137 over 2. So that's actually ugly, and it takes you a while to blast that in, but that's going to be our answers right there, buddy. So lots going on. Bit of a recap, if you will. Basically what we started with was factoring out the common term. We couldn't factor the trinomial, so I got rid of the c term, the whole number part, and then I made a perfect square trinomial by adding half of the middle term squared. We add that to both sides, we factor the resulting trinomial, and then we just do algebra. Here I took the square root of both sides and expressed our answer. All right, so I hope that helps. Let me know if it doesn't, and keep on keeping on.